go through 12.3, divide polynomials. Most of you got very good at this, so I'm hoping this is not a hard review for you. I'm going to go through the evens, and I really suggest that you do them now and then check your work with the ones that I'm going to work out right now as if we were in class. So here's number 12. Y squared minus 5y minus 8 divided by y minus 3. We're going to put this in division format. Y squared minus 5y minus 8 divided by y minus 3. It's important that you just talk yourselves through it as you do it. It makes a very big difference in terms of getting it right. So what times y is going to give me y squared? Y. Y times y is y squared. And then the second term, y times negative 3 is negative 3y. When I subtract, I'm going to change the signs to subtract, I end up with a negative 2y, and then I carry down my 8. Let's go through the process again. What times y's will give me negative 2y? Well, clearly just negative 2. So negative 2 times y gives me negative 2y, and then negative 2 times negative 3 gives me positive 6. I'm going to subtract these two. After changing my signs, I end up with negative 14. And so I have y minus 2 plus my remainder of negative 14 over y minus 3. And that is my answer to that division. Let's do number 14. I have 3a squared minus 2 divided by 3 plus 3a. Now some of you are already cluing in that you cannot possibly divide these as is. And I probably should have gone through the process with you here. So let's do it now. In order to be able to divide these things, these have to be in descending degree, where you've got a variable squared, something times squared plus or minus something times a second degree, first degree, and then a number. So 1, it has to be in descending degree. 2, there have to be no missing terms of a given degree. What do I mean by that? I mean that I can't just have 3a squared minus 2 because I'm missing the first degree term. I'm missing the a term. So what do? Can I still do the division? Yes, and we did go over this when we did 12.3, but we didn't go over it often, so I want to redo it here. So when you do that, you have to add the missing term in. So here is my second degree term. And what you do is you add a dummy term as a placeholder. So plus 0a, which basically if you multiply, you get 0. But in the meantime, you're holding the space for that first degree term, minus 2. So then I also want to put on this side, divide 3 plus 3a, but the problem is it is not in descending degree. So here I made sure it's in descending degree and I have no more missing terms. Here, if I go 3 plus 3a, I'm starting with the degree of 0 and then having the degree of 1, and these need to be flipped. So I need to have the a term, or the first degree term here, plus 3. Now I'm ready to go. What times 3a gives me 3a squared? A, and I get 3a squared. And then a times 3 is 3a. And you can see very clearly right here why you needed that 0a term. When I do my subtraction, I end up with negative 3a, and I can carry down my minus 2. What times 3a will give me negative 3a? Well, negative 1. And when I do that, I get negative 3a. Negative 1 times 3 is negative 3. When I subtract them, changing my signs, I get a remainder of 1. And so my answer is a minus 1 plus 1 over 3a plus 3. And I'm finished. I am not going to do the word problem with you, but I'm going to help you set it up, or at least start to set it up, because it does ask you to do a graph, I believe, write and graph an equation, but I'll take you through at least the equation. This is number 15. Sean intends to collect $500 in individual donations. So you need to write these things down, right? So you keep track of what's going on. His company will contribute $2, so contributes $2 per donation. Oh, my pen's running out of ink. That they collect. So he's going to collect $500, right, in individual donations. We don't know how many there are, so, right, we're going to get $500. We don't know how many there are, and he's going to give $2 per donation. And we don't know how many, right? But we need $2 per each donation. Write and graph an equation that gives the average amount that the charity will receive per donation. The charity is going to get the initial donation plus their $2 donation, right? So they're going to get up to 500 in individual donations, plus for each of these an additional $2 contributed by the company. So we want to know, what does that add up to? It's going to be more than the $2, obviously, because it's going to include the 500. So we want to know what the average contribution, including the company contribution, is going to be. So this is going to be a per donation amount. And so we know that this $2 is already per donation, so we can leave it. But this is not. And so we need to divide it by all the donations in order to get the correct amount. Now you could choose to leave the equation this way, or you could also choose to combine this equation. Sorry, I should have not done this over D. This is already per donation. And to combine these, you want to multiply top and bottom by D. So 500 plus over D plus 2D over D. And now you have your full equation. A equals 500 plus 2D over D, or you could just leave it as 500 over D just plus 2. All right, well that takes care of 12.3. And I'm going to stop the video and combine in the next video 12.4 and 12.5.